Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to the subject of radar systems and engineering. And in the previous video, we discussed about the various characteristic features related to radar measurement uh, in terms of range, elevation angle, azimuthal angle, that is resolution, imaging, signature, the target signature, and a lot of other things, range resolution, cross range resolution. So in this video we are going to discuss about the concept of velocity measurement of target objects using radar, which is based on the frequency shift concept. So we all know that the radar, which is basically the acronym for radio detection and ranging, it uses electromagnetic waves, okay, to detect the location and various features associated with target objects which are at very long distances. And the basic concept, it involves transmitting electromagnetic waves of a certain frequency which strike the target object, then they get reflected back, which is called as the echo signal, and then the echo signal is processed, analyzed using various circuitry, and then the resultant uh, signal is displayed, with the help of which we get various kinds of information about the target. So an important component of this whole measurement, which is the velocity measurement, which gives us information about the speed, the velocity of the target object, that is uh, processed with the utilization of Doppler effect, that gives us information about the target's velocity. It is based on frequency shift, frequency change between the transmitted and the reflected or received echo signal. So before doing that, we should understand what Doppler effect is and how it is utilized to get us information about the target velocity. So Doppler effect is the phenomena which causes a difference between the frequency at which, whether we are transmitting sound or light waves, the basic principle, from a source, and at which they reach the reflected signal, it reaches the observer or listener. So this happens when either the observer or the source, it is they're moving with respect to each other, they're in relative motion. But most of the time, what happens in case of radar, the target, it can be stationary or moving, but the radar antenna, it is fixed. So the radar antenna is fixed, the radar system is fixed, but it is the target which is mobile, which is moving. It can be fixed too, but it can be mobile also. So when it is mobile, when it is moving, at what velocity it is moving, that is that information we get by the utilization of Doppler effect. So Doppler effect causes a frequency shift between the transmitted and the reflected sound or light waves, electromagnetic waves. So how much shift occurs, that is given by Doppler effect. So it was first given by, this theory was proposed by Austrian physicist Christian Doppler. So the mathematical formula that gives us the velocity and frequency shift relationship is given by this: F subscript L is equal to V plus VL by V plus Vs F subscript S. So here F subscript S is the frequency of light or sound, the electromagnetic wave which is emitted from the source. Okay, at what frequency the electromagnetic wave, which can be light or sound, whatever it is generated from the source. Then FL is the frequency at which it reaches the observer or the listener, and then V is the velocity of propagation of the electromagnetic waves in the medium in which it is traveling, normally air. And VL is the velocity of the listener, and Vs is the velocity of the source. Now this is basically which we have studied in high school, this formula to understand Doppler effect, and an example of which is that suppose we move towards a car which is continuously honking, blowing its horn. So the sound which we get, the pitch of the sound which we hear when we are far away from the car, it continuously starts to increase when we move towards it. Suppose we are traveling in a car and a car which is ahead of us, it is continuously blowing its horn. So when we are far away from it, the pitch of the sound which we get, it continuously starts to increase in its intensity when we approach the car, when we get close enough to the car. So that is because of the phenomena of Doppler effect. So this concept is utilized in radar system to get us information about the velocity of the target. So here the VL component comes into play because the source is generally fixed, the radar system is fixed. So how this concept is utilized in radar? Here the radial velocity of the target is generally obtained. So what is radial velocity? Suppose we have the target object, let us say this plane. It is traveling at a certain velocity represented by this velocity vector, this vector, okay. Now when we resolve this vector into two components, we have a horizontal component and a vertical component. So this horizontal component, this is called as radial velocity, and this vertical component, it is the tangential velocity. Now we are particularly interested in the radial velocity, which is directed towards the radar. So this radial velocity, it is related to the frequency shift or the difference in frequency between the transmitted signal from the radar and the received echo signal. So that frequency shift is given by Ft is equal to Fr minus Ft, where Fd is the Doppler frequency shift, this is the frequency of the received echo signal, this is the frequency of the transmitted signal, all in hertz. So the radial velocity, this radial velocity, the horizontal component of velocity, it is related to the Doppler shift as per this mathematical formula. So the Doppler shift is given by this mathematical formula, which is 2ft Vr by c cos gamma, where Ft is the transmitted signal from the radar, the frequency of the transmitted signal. V subscript r is the radial velocity component. C is the velocity of propagation of the electromagnetic wave in free space, which is generally 3 into 10 to the power 8 meter per second. Then we have cos gamma, where gamma is the angle between the radial velocity component and the total velocity component. So the radial velocity component is generally in line with the radar antenna. So it is the angle between the radial velocity component and the total velocity component of the target, that is cos gamma. So this is the relationship between the Doppler shift and the radial velocity. Now we all know the Ft, the transmitted signal frequency, gamma, C is fixed, Doppler shift we get. So from all this we can calculate the radial velocity component. And in certain cases where the radial velocity component is much lesser than the speed of propagation, in that case the equation is modified to simply Fd is equal to 2ft Vr by c. The cos gamma component is not here in this case. So this is a very simple case, in a simple way in which we can determine the radial velocity component from all of these parameters: the angle between the radial and total velocity components, the transmitted signal frequency, the speed of propagation, and the Doppler shift. So this is one of the basic concepts related to velocity measurement, basically the radial velocity measurement. So once we get the radial velocity measurement and we have this gamma, we can also determine the tangential velocity using the basic rules of trigonometry. So these are some of the basic things related to velocity measurement. So the radial velocity is important because it is in line with the radar antenna. Okay, so that we can determine directly. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.